Now, if we go to the syllabus sequence, first two modules we have substantially covered with. The third module is of inner product, is debatable to be sequence number. So we find that in many books the linear transformation comes first, then eigenvalues, and then the inner product. So we'll go in that sequence. So listen very carefully. I am trying my level best to simplify the things which are otherwise available to you. Linear transformation, hoping that you might have gone through it. Can anybody talk about what do we mean by linear transformation? Let us now listen very carefully. Let us try to focus on 2D space first. Let us try to focus on 2D space. What is transformation? Transformation is change, rupantara. Transformation is changing. So there are many ways of what can be the mapping for transformation. I will explain it with simple most examples which you are expected to easily understand. So let us talk about a 2D space O origin and any point on the plane. So a vector, to be very precise again, it's again notion joining the point from 0 to that point, origin to that point, we assume to be a vector, but that is just for our satisfaction. In general, a point P having some coordinates, say it is having coordinates of 3, 3, is a point, right? So point Q is -2 plus 1.5. We can use plus sign positively so that there should not be any confusion. Is it clear? So a point in a 2D, or in general, to be very precise, position in a 2D plane is considered to be vector over real number space of dimension 2. If R is real number, then two-dimensional space, when you consider, any position is a vector. So what do we mean by position? Ordered pair. In a 2D plane, position is an ordered pair. Is it clear? So given position is a vector. Now I will try to make the things difficult first in the sense that I will give the classical definition, and I will find that it is not so easy to understand the classical definition, and then we go for the simplified description, we can say, not definitions, description. So to just verify that whether you understand or not, I read the definition and you should tell me what does it mean. Listen very carefully. Again, the description also, we will find that many things are just beyond our common language. In mathematics, every line of inquiry ultimately leads to a description of some set and function on that set. One may metamorphically refer to, what do we mean by those who are in English medium in 10th, what do we mean by metamorphically? Anyway, sometimes you can nowadays, Google has made the job simpler. Otherwise, to search in dictionary, how it would have been difficult maybe 3-4 decades back. Anyway, but one more thing is that to understand the theme, meaning of all words is not essential. We can have some kind, just like what I say, that even a blind can have a perception of things. What are you doing? Hello? Look here. A blind can have perception of things without seeing them. Like that, we can perceive the things without understanding each and every word. It is also possible. But anyway, you try to read the meaning through dictionary and through Google and find out. One may metamorphically refer to elements of the set as nouns and functions that operate on the elements as verbs. Elements of set nouns and functions as verbs. In linear algebra, the sets are vector spaces, which we discussed earlier, and linear transformations on vector spaces are the functions. So that is just what we can say preamble. Now the definition. If V and W are vector spaces, then a mapping T from V to W is a function that assigns to each vector V bar in vector space V to a unique vector W bar in vector space W. In this case, we say that transformation T maps V to W for each vector V in vector space V. There is a vector W in vector space W. So W is said to be transformation of V, that is image of V in W. Image of V in the transform space under the transformation T. त्याचं काय कळलं? So that's what we try to simplify. Say, in general, we may use it for some kind of complex operations, or for transformation means you may be aware that it is some kind of coding and which is known by those who talk and those who listen and not known by the others. So they get the information but can't interpret it. So what is done? To be very, I will explain all these things in a simple manner. Right now we consider that the two-dimensional space only. So what we do? We map here. There is first, just in front of this, maybe 1 foot ahead, I will have another plane. Well, try to understand. And what I do is that a point P in the original plane gets shifted to another point P dash in the image plane. A point P in original plane gets in the original plane, and just here is the image plane. So point P there gets mapped to point P dash in my image plane. Now, how there should be mapping? It's just like, listen very carefully, try to understand. Students are sitting in this classroom and I want that there is some test and they are having a convenient sitting arrangement for the test. So I want to change that. So there is another rule. Again, it's a two-dimensional plane. Row number, column number, positions are there. And another room is exactly identical with this room. What I will do, I will call row number 1. He will stand up. He is at some position, right? I will take him with me, take him to other classroom, and ask him to sit at the position which I state to be. So like that I do. So there are different ways. One is random mapping. One is random mapping. With that random mapping can also be unique. Random mapping can also be unique. Random mapping can also be unique. For every position in original plane, there will be a fixed position in image plane or transformed plane. Listen very carefully, try to understand. For every position P, what is vector? Position P in the plane is a vector. It is ordered pair. It's a two-dimensional vector space. For every position in original vector space, original plane, there will be an associated position in the transformed plane, image plane for P, P dash. Or you may say P1, P1 dash, P2, P2 dash. Any point you take, there will be a unique, means one point will get mapped to a fixed image. म्हणजे आता मी एकाला उठवलं तर त्याला मी त्याच कुठल्या एकाच ठिकाणी त्याला दोन ठिकाणी सांगणार नाही. So there is a mapping between the original vector space and transformed vector space or image vector space. Now what can be the ways? Now it's a two-dimensional plane, right? So if you I write like this, I can write like x comma y also, but this is if we x y. If u is x y, means there are two coordinates. It is an ordered pair. So u bar is a vector in two-dimensional real space. U bar is a vector is in a two-dimensional vector space. So that should get mapped to v bar. U bar should get mapped to v bar. So x and y should get mapped to something. Then when you can call it as a linear transformation. When you can call it as a linear transformation. Each point is to be like बघा आता मराठी सांगतो. मूळ प्लेन वरचा प्रत्येक पॉइंट हा असोसिएटेड जो ट्रान्सफॉर्म प्लेन तो दुसऱ्या ठिकाणी न्यायचा आहे. प्रत्येक पॉइंटला त्याच्या इमेज प्लेन मध्ये एक दुसरी जागा असेल. तीच जागा असू शकते. I is identity transformation. I is an identity transformation. लक्षात का? दिलेल्या प्लेन मधल्या प्रत्येक जागेला, प्रत्येक पोझिशनला किंवा प्रत्येक वेक्टरला ट्रान्सफॉर्म डोमेन मध्ये, ट्रान्सफॉर्म 2D स्पेस मध्ये, ट्रान्सफॉर्म प्लेन मध्ये एक दुसरा वेक्टर असेल, दुसरी पोझिशन असेल. तर ती कशी मॅपिंग करतात? दिस इज कॉल्ड ट्रान्सफॉर्मेशन. ट्रान्सफॉर्मेशन मीन्स for everything in original there is some unique thing in image or transform space. Now when it can be said to be linear transformation? For each vector in original space will get mapped to a unique vector in the transformed space. So for everything, every vector in V, capital V, there will be another vector in capital W. Right now we have taken dimensions to be same. They need not be same. We also discussed that later on. So right now, what is we mean by linear transformation? mean by linear transformation? So we say mapping T from R square means R square what does it mean? Two-dimensional original space, two-dimensional transform space. What is that? T, so we say like this, T, the given vector x, y is equal to, no need to write this, like it is a transformation operation. What can be म्हणजे प्रत्येक एक्स वाय ला एक्स वाय असं लिहितोय किंवा सेम आपण असं पण लिहू शकतो एक्स कॉमा वाय म्हणजे पोझिशन लक्षात आलं का? इट इज अन ऑर्डर वेक्टर इज अन ऑर्डर कॉम्बिनेशन लिहिताना आपण असं लिहितो हे लक्षात ठेवा. फॉर एव्हरी एक्स वाय देयर विल बी सम अदर थिंग इन ट्रान्सफॉर्म डोमेन. मग लिनियर कधी म्हणायचं? एक तर रॅन्डम ट्रान्सफॉर्मेशन म्हणजे मग मी याला उठवणार तिथं पुढे जाऊन बस. लक्षात आलं का? व्हॉट इज ट्रान्सफॉर्मेशन? म्हणजे ट्रान्सफॉर्मेशन हॅज नो रिस्ट्रिक्शन ॲज सच. ट्रान्सफॉर्मेशन मीन्स जस्ट चेंजिंग फ्रॉम वन टू अदर. याला उठवणार माझ्या मनाला इथं बस म्हणणार, याला उठवणार, दॅट इज ऑल्सो ट्रान्सफॉर्मेशन. पण ते लिनियर कधी? बरं लिनियर नको, त्याला काहीतरी सूत्र आहे तर ते रॅन्डम ट्रान्सफॉर्मेशन पण कन्सिडर करत नाही. सम फॉर्म्युलेशन शुड बी देअर. सो व्हेन वी कॅन से इट्स अ लिनियर ट्रान्सफॉर्मेशन, when we can say it's linear transformation, when if for a vector x comma y or xy column vector in U in vector space V, in vector U ने क्या बोले? I think they have used V and W. So V नहीं U and they have used U. Those are V and W. V and W. So if each of them is linear combination of आता एक आपण हे घेऊया एक्सपॅन्डेड स्पेस म्हटलं तर म्हणजे पुढे गेलो आपण आणि कुठून तरी मागून एक असा लाईट सोर्स आहे, एकदम असे काही अंतरावर लाईट सोर्स आहे, इथं प्लेन आहे, त्या लाईट वरनं इथं आलो एका पॉइंटला, या प्लेनवर एका ठिकाणी बोक पाडलं. अगदी सोप्या सोपं करून सांगतोय, हे गरज नाही. इथे एक लाईट सोर्स आहे छोटा, इथे प्लेन आहे, प्लेन पूर्णपणे ब्लॅक आहे, त्याच्या एका ठिकाणी होल पाडलं आणि इथं लाईट सोर्स आहे, इथं प्लेन आहे, इथं प्लेन आहे. हे प्लेन ब्लॅक आहे, इथे एका ठिकाणी होल पाडलं तर त्या प्लेनवर कुठल्या तरी पोझिशन लाईट येईल, तर ह्या होलचे पोझिशन त्या लाईटचे पोझिशन मॅप होईल. ही दुप्पट 2x 2y. Many options are possible. Will it be all right? It is a transformation but not linear transformation. Linear way. It's not linear. लिनियर कॉम्बिनेशन मध्ये कॉन्स्टंट येत नाही. आता त्यात दोन तीन आहे, हे फक्त x पाय असं नाही आहे. सो दिस कॅन ऑल्सो बी अ कॉम्बिनेशन ऑफ x अँड y अँड दिस कॅन ऑल्सो बी कॉम्बिनेशन ऑफ x अँड y. दिस कॅन बी कॉम्बिनेशन ऑफ x अँड y, दिस कॅन बी कॉम्बिनेशन ऑफ x and y. सो a1x plus b1y, a2x plus b2, a2x plus b2. Is it right? Is it okay? It's all right. So this is a linear transformation from original vector space to new vector space. Original vector space to new vector space. So original space, it is image space. Is it okay? So what we should have? We should have a linear combination of each of them. एक TL applicable है. Is a linear combination of the other. Is it right? Now, then there are few simple things, just put in some complex terminologies and all that. Is it clear? So, now, is this invertible? Is it invertible? बघा लक्षात, अगदी सोपं आहे. आता इथे पण आपण व्हॅल्यू घेऊया. काय घेऊया? a1 a2 b1 b2 घेता सोपं घेऊया. सोपं काय घेतो आपण? x plus y minus y. Right? This is u. Sorry, this is v. म्हणजे where 1 1 we mapped, 1 1 we map to, बघा लक्षात, अगदी एकदम सोपं आहे, काही तर रॉकेट सायन्स नाही. 1 1 we map to 2 0, 0 0 we map to 0 0. आता आपण घेतो ना लिनियर कॉम्बिनेशन मध्ये कॉन्स्टंट घेतलेलं नाही आहे. तो घेतला तर कसं शिफ्ट होईल, नंतर अभिषेक घेऊया. इज इट क्लियर? सो राईट नाउ वी आर मेकिंग इट व्हेरी सिंपल. 2 2 will map to 2 2 4 0. So what we get, somehow the points actually, एक फार जे काही कम्प्युटर सॉफ्टवेअर मध्ये एक्सपर्ट असतील तर त्याचं उत्तम प्रकारचं ॲनिमेशन करू शकतात. 2 प्लेन घ्यायची आणि इथं कसा आहे आणि इथं कसा येतो. 1 1 1 1 चा आहे तो इथं 2 0 येतो. म्हणजे आता कसे जातात ना, P x y leads to x plus y, x minus y, right? So 0 0 gets mapped to 0 0. Now 1 0 will get mapped where? This I say 1. It will get mapped where? 1 0. 1 0 will get mapped to 1 1. 1 0. 1 plus 0, 1 minus 0. Camera A A. राइट मॅप करतात. 2 असे रे आपले बोर्ड नाही आहे. हाफ हाफ half half, right? Half half. How one? Minus 1 0, minus 1 0, minus 1 0, minus 1 minus 1. Minus 1 1, minus 1 1, minus 1 1, minus 1 plus 1 0, minus 1 minus minus 1. It means 0 minus 2. Is it right? Minus 2 2, 0, two minus 2, 2 minus 2, 0, and 2 minus minus 2. Is it right? 2 minus 2, 2 minus minus 2. Is it okay? Right? So this is the way with which the original and image are there, where this is a transformation. Now, task before you is to find other transformation S such that you should find transformation S. T mean what we are having? T of right? Find transformation S such that for every vector in space capital W, you get the original vector back. So what is this? Find the transformation S. This is called as inverse transformation. What it would be? Like, you got a question? Everybody has to find them. So what you should get? x plus y and x minus y. From that you should get x and y. Right. So what we must have? It's again, it's a linear combination again. So a1 x plus y plus b1 x minus y and a2 x plus y plus b2 x minus y. And what we should have? a1 x minus y plus b1, so x plus y plus b1 x minus y should be equal to x, and a2 x plus y plus b2 x minus y should be y, right? So what we get here? a1x plus b. So how many variables are there? How many variables are there? a1 b1 a2 b2. a1 b1 a2 b2. And how many equations are there? Four equations. How? Here x and y terms don't mix. म्हणजे एक्स आपण सर्किट थिअरीला आता विसरून गेला असा तुम्ही एक्स इक्वेशन असतं ई रेस टू लॅम्बडा एक्स असतो आणि नसतो. मग ज्या प्रत्येक बाजूला वेगवेगळे टर्म्स असतात, काही ई रेस टू लॅम्बडा एक्सच्या टर्म्स, काही ई रेस टू लॅम्बडा नसलेल्या टर्म्स. मग अशा एका इक्वेशन म्हणून दोन इक्वेशन तयार होतात. म्हणजे ई रेस टू लॅम्बडा एक्सच्या टर्म्सचे कोएफिशिएंट इक्वल पाहिजेत, ई रेस टू लॅम्बडा नसलेल्या टर्म्सचे कोएफिशिएंट इक्वल पाहिजेत. तसं याच्यामध्ये एक्सच्या टर्मचे कोएफिशिएंट इक्वल पाहिजेत, बोथ साइड्स वायचे इक्वल पाहिजेत. आता फॉर्च्युनेटली इथं वर कसं आहे, वाय नाही आहे, म्हणजे वर काय 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 येणार त्यामध्ये? व्हॉट वी गेट? एक्सचं काय काय आहे? a1 प्लस b1 इक्वल टू 1 आणि a1 मायनस b1 इक्वल टू 0, राईट? म्हणजे चार व्हेरिएबल जरी असली तर ही दोन आहेत, खालची वेगळी आहेत. म्हणजे वर a1 b1 आहेत आणि एक इक्वेशन असते त्या दोन इक्वेशन आहेत. So that what we get adding these two a1 equal to 1, a1 equal to half. I am putting a1 equal to half, b1 equal to half, right? So a1 equal to half, b1 equal to half. इधर क्या होता है? क्या कहते हैं? हाफ आणि a2 plus b2 equal to 1, a2 minus b2, so a2 plus b2 equal to 0 and a2 minus b2 equal to 1. So a2 is half and b2 is minus half, right? So the transformation, the transformation is, if I say that s इथे मी जर x y दिलं तर what it would be? Half half. Right? This is its inverse. This is inverse. Now we can also have a transformation from, listen very carefully now, we get a projection. We get a projection. So for every point, listen very carefully, for every point in a 2D plane there is a projection on x-axis. So how will you have the vector space W the original space what does it mean? Again there is for a position for a position in 2D plane there is a position on x-axis projection. It is unique, right? But is it invertible now? You can construct by some kind of rotating or all that. It's not invertible. You can't get your original thing back. So, in general, a linear transformation means original vector space, you get image vector space. The image vector space can be, again, we can have, then dimension need not be equal. If this is 2, this can be 2. It can be 1. It can be either x or simply x plus y. Simply x plus y. That can be other way around. Or it can be 3. Can be 3. So from 2 I can get 2, 1 or 3. From 3 I can get 3, 2 or 1 or even 4. Then for invertibility, we must have equal things. So, the theme of linear transformation is clear. In the image vector, what is vector? Ordered combination. Every, अगदी सोप्यात सोपं सांगतो. वेक्टर म्हणजे काय? ऑर्डर कॉम्बिनेशन. तर लिनियर ट्रान्सफॉर्मेशन म्हणजे काय? दिलेल्या वेक्टर स्पेस मधल्या प्रत्येक वेक्टरचं जे एलिमेंट आहे, प्रत्येक वेक्टर जो आहे तो इमेज स्पेस मध्ये अशा ठिकाणी ट्रान्सफॉर्म होतो की त्याच्यामधल्या म्हणजे दिलेला वेक्टर म्हणजे काय? वन गिवन कॉम्बिनेशन. For a given combination in original vector space, another combination in image vector space is mapped such that each element of the vector or each element of that combination is a linear combination of elements of the given combination. दिलेल्या वेक्टर स्पेस मध्ये एक वेक्टर आहे. वेक्टर आहे म्हणजे एक कॉम्बिनेशन, an ordered combination. So the ordered combination in image space is such that every element in the image, in the ordered combination, every element of the combination in image space is a linear combination of all elements in original space. Number of dimensions can be equal or they can be unequal. The question of invertibility is there if they are equal. Is it okay? So you try to watch the things.